Hey everybody, welcome to the let's see, I want to make sure my mic is working right here. Seems like it's all right. So welcome to the guided assignment for chapter 7. And I'm just going to jump right into it. Remember, these are sampling distributions. And so we have to work with a couple different things, okay? Remember, first of all, we're trying to figure out if it's a sampling distribution of X, meaning it's based on some value of X, or if it's the sampling distribution of P based on some proportion. You can usually tell because the values of X that you're dealing with are in numbers that are greater than 1, okay, as opposed to proportions, which are always some percentage, some decimal between 0 and 1. Okay, so let's take a look at this first one. The population has a mean of 200 and a standard deviation of 50. Suppose a simple random sample of size 100 is selected, and X bar, meaning the sample mean, is used to estimate the population mean. So what's the probability that the sample mean will be within plus or minus 5 of the population mean? And what's the probability that it'll be within plus or minus 10? Okay, so the way we have to tackle this, and whenever I'm not sure how to tackle something, I just start by like writing down everything I know. Okay, so I'm gonna be like, I know the population mean is 200. I know the standard deviation of the population is 50. I know the sample size, which is n, is 100. So that's what I know to start with on this problem, okay? And that usually helps me get a starting point. Now, the first question is asking me, what is the probability that the sample mean will be within plus or minus 5 of the population mean? So whenever I'm finding like the sample mean or some value of X based on the sample mean, I need a number that's called my standard error of the mean. So I always abbreviate it SEM. And you can find the standard error of the mean, okay? It's the square root of the standard deviation over n. And you can find that formula in your book. Give me a second. I'll even tell you what page. I'm sorry, I told you it wrong. Actually, it's the standard deviation over the square root of n, not the square root of the standard deviation over n. So the standard error of the mean is the population standard deviation over the square root of n. So we'll say this equals the population standard deviation divided by the square root of n. So what this number really does is it helps us figure out the standard error, which is a function based on not only our standard deviation. If you think about it, the standard deviation is a form of standard error, right? We take each value of x, or the mean, each value of x minus the mean, and then we square it, and then we add them all up, and then we divide it by the total number, right? That's how we find this, and then take the square root of that. That's how we find the standard deviation. But if we're taking a sample of a larger population, we also have to factor in the sample size. So the standard error of the mean does that. Just remember, it's always the population standard deviation divided by the square root of n, of little n, the population size. All right. So once we know the standard error of the mean, we can go ahead and figure this out. So like I could find out, first I need to know like what is my value of x that I'm looking for. And because it's giving me two values of x, it says plus or minus 5. I'm going to do an x and an upper x, which is just going to be my mean plus 5. And then my lower value of x is just going to be my mean, minus 5. So because it's asking me, what's the probability the sample mean will be within plus or minus 5 of the population mean? So I'm saying, what's the probability that my sample mean is going to be within 195 and 205? Okay, that's really what it's asking me. So now I can find the probability of the upper, right? So we learned how to do this last chapter. I'm just going to equals norm.dist, where x, what I'm going to use for x is going to be the x of the x value of the upper. For mean, I'm just going to use my population mean. And instead of standard deviation, I'm going to use my standard error of the mean. So with that function, I find that the probability that given a population mean of 200 and a standard error of the mean of 5, the probability of x being 205 or lower is 0.8413. And do the same thing here, norm.dist. My value of x is now going to be the x lower. The mean is going to be my population mean. The standard deviation is I'm going to use my standard error of the mean. I'm going to hit true. So the population, or the probability then that it is 195 or lower is 0.1587, okay? So the probability that it's between those two, because that's really what the question is asking. The probability that it is within plus or minus 5, so between 195 and 205, is just the probability of the upper minus the probability of the lower. So since it wants me to round this to 4 decimals, I'll let it do the work for me. So that's going to be 0.6827. Check our work, make sure we're on the right track. And we are. And then the second question says, what's the probability the sample mean will be within plus or minus 10 of the population mean? So I can go in here and just change my x upper to the mean plus 10, and my x lower, the mean minus 10. That's going to recalculate my probabilities. And so my probability is 0.9545. We can see that we really increase our probability a lot by increasing the range that we're looking in, right? The probability that it's within 195 and 205 is only 68%, 68.27%. The probability that it's between 190 and 210 is 95.45%. All right, so there's our first one. Our second one says, suppose that a random sample of size 50 is selected from a population with a standard deviation of 10. Find the value of the standard error of the mean in each of the following cases. So really, again, start with what we know. We know sample size, n, is 50. And we know population standard deviation is 10. And then we can see down here that it's going to give us our population sizes, which is another indicator for population size is big N, okay? And in the case of this first one, big N is 50,000. Okay, so this one is going to help us understand if whether or not we need to use the finite population correction factor, and then how to apply it. So remember, the rule is if little n divided by big N is 0.05 or greater, so if our sample size is 5% or greater of our population size, we'll have to use a finite population correction factor, okay? So I like to do a little n divided by big N here, and then I just take little n divided by big N, and I can see that in this case, little n divided by big N is 0.001, which is definitely not bigger than 0.05. So I know I won't need a finite population correction factor for when we have a big N of 50,000. So, all right, so let's just go ahead though, and let's figure out our standard error of the proportion. Remember, our standard error of the proportion equals our standard deviation, population standard deviation, divided by the square root of n. So when we don't, so this first one says when the population size is infinite. So if the population size is infinite, then definitely little n divided by big N is not greater than 0.05. So our standard error of the proportion, what does it want? 2 decimals is going to be 1.41. Now, when our big N is 50,000, we still don't have to do a correction factor because our little n divided by big N is not greater than 0.05. So it's still going to be 1.41. If we change our big N now to 5,000, now we see little n divided by big N. So sample size divided by population size is 0.01 or 1%. So still no correction factor needed. The last one, we have a big N of 500. So there we can see that now our sample size divided by population size is 0.1, which is bigger than 0.05. So we're going to have a finite population correction factor. I just abbreviate this FPCF. You can call it whatever you want. That's a finite population correction factor. And the formula for this, again, you can look it up in the book, but it's the square root of big N minus little n divided by big N minus 1. Okay, so square root big N, which is the population size. Whoops, I didn't do an equal sign, sorry. Big N minus little n divided by big N minus 1. So that'll give us our finite population correction factor. And so then if we multiply our standard error of the proportion, I'm sorry, standard error of the, I called it, it should be the standard error of the mean. I did that on the last one too, didn't I? No, I called that one the standard error of the mean. So if I multiply my standard error of the mean times the correction factor, that gives me the corrected standard error of the mean. And so instead of 1.41, it's 1.34. And remember, what we're doing here is we're doing this correction because the sample is such a large amount relative to the mean that we want to actually put this correction factor to introduce some of that error and have I guess a slightly lower standard error of the mean. Okay, I can check my work and see that they're all right. But what's interesting, right, if we go back to the one that's 50,000 and we did a big N of 50,000, we would see that because our little n divided by big N is so small that our finite population correction factor becomes pretty much irrelevant, right? And so the number still comes out to 1.41 even with correction. And even if it was 5,000, we would see again, it still comes out even corrected. So, and that's why, but it's still better to just test and say, is my little n divided by big N greater than 0.05? So let's move on to number 3. So number 3, we're getting into the sampling distribution of a proportion. So again, we can recognize this as a proportion because it almost always starts with something like assume the population proportion is 0.55, or that somebody thinks they have a proportion of 0.4 or whatever. So that can help you identify it when there's not a label telling you right here. So I'm gonna, pardon me, again, because I'm not sure how to proceed, I'm gonna start with what I know. And so I know that the population proportion, which is just called P, is 0.55. It wants me to compute the standard error of the proportion for a given sample size. Okay, so some value of n. And the first one it gives us there is 100. So the standard error of the proportion is another one of those things that you just have to know the formula for. The formula is in the book if you need it. and it's on page 333, 332, and 333. But it's always the square root of P, this is the population proportion, times 1 minus P over N. Okay, so I'll write that this way in Excel, equals square root of P minus, or sorry, times 1 minus P over N. And that's it. So there's our standard error of the proportion. This is the same thing, okay, if we have a situation where our sample size is greater than 0.05 of the population size, then we'll do a finite population correction factor. On this problem, they don't tell us what the big N is, what the population size is. So in those cases, we just assume it's infinite and don't worry about correcting. Okay. All right. So if I have so it wants these to 4 decimals. So I have 0.0497 is my standard error of the proportion with an N of 100. If I increase my N to 200, so I take a larger sample, now it's 0.0352. If I increase my N to 500, it's 0.0222. And if I increase my N to 1000, it's 0.0157. So then it says, what can you say about the standard error of the proportion? The size of it as the sample size is increased, and we can see the larger our sample, the less error we have. Okay, and that makes sense. We're just going to get something closer to what the population is if we take a larger and larger sample. So we're going to say standard error of the proportion decreases as the sample size increases. All right, and finally we'll go on to number 4. So number 4 here, we have the president of Dorman Distributors, Inc. believes that 30% of the firm's orders come from first-time customers. A simple random sample of 100 orders will be used to estimate the proportion of first-time customers. Assume that the president is correct and P equals 0.3. What is the sampling distribution of P bar, okay, which would be the proportion of the sample for this study? And so we know that it's good. This is just something out of the book. Don't worry too much about it. But in order for us to be correct here, okay, it has to be that it's a normal distribution, because NP, so the sample times the proportion, and N times 1 minus P are both greater than 5. Okay, that's how we know if it's normal size. So N times P, 0.30 times 100 is greater than 5. And then 1 minus P, which is 0.7 times 100, also greater than 5. So that's how we can tell if it's normally distributed. Okay, and then it asks us, what's the probability that the sample proportion will be between 0.2 and 0.4? All right, so again, when in doubt, start with what you know. So I know that P, or that at least we believe P, the population proportion, is 0.3. I also know N is 100, and I can use that to calculate the standard error of the proportion. So remember, the standard error of the proportion equals the square root of P times 1 minus P divided by N. And again, because we don't know the big N, we don't know the population size, we are going to just go ahead and assume it is infinite, meaning we don't have to worry about a finite population correction factor. All right, so when we know the standard error of the proportion, and we know the proportion, and we know N, we can start to calculate probabilities of things. So again, I'm going to have my X upper, or I should say my proportion upper is 0.4, and my proportion lower is 0.2. And then the probability of that upper figure of 0.4 and the probability of that lower figure, 0.2. So the probability of the upper proportion, okay, I'm going to hit equals norm dot dist. For x, I'm going to use p, so the proportion, the population proportion, comma, the mean. Oh, I take it back. I lied to you. For x, I'm going to use, sorry, my proportion of the upper, right? And then for the mean, I'm going to use the population proportion. And for the standard deviation, I'll use the standard error of the proportion and then hit true. So this will give me the probability that given a population proportion of 0.3 and an n of 100, that the proportion will be 0.4 or less. To find the probability of the lower, I'll do norm dot dist. For x, I'll use the lower proportion. For the mean, I'll use the population proportion. For the standard deviation, I'll use the standard error of the proportion. That gives me the probability of the lower. So again, given a population proportion of 0.3 and n of 100, the probability that the proportion is 0.2 is 0.014548. So then the probability that it comes between those two just equals the probability of the upper minus the probability of the lower. Again, it wants us to do 4 decimals, so I'll let it do the work for me. And it's 0.9709. And then the second one says, what's the probability the sample proportion will be between 0.25 and 0.35? So for upper, I'll put 0.35. For lower, I'll put 0.25. And now my probability is 0.7248. So we can see that by narrowing, right, the upper and lower range, we lower our probability that it falls between there, which makes sense. We'll check our work. We're good. I hope that was helpful, and I hope it helps you as you launch into the homework, and I hope you have a terrific week.